Hi there. This interview is about how logs, metrics, and traces are actually used in real systems, not how they are defined in documentation. I will ask questions that reflect what happens during incidents, performance investigations, and production debugging. As you listen, pause the video after each question and answer it out loud as if you were in the interview. Then listen to the sample answer and compare how you reasoned, what you focused on, and what you might improve. If you want more realistic DevOps interview simulations like this, subscribe so you do not miss the next one. Warm-up behavioral questions. Tell me about a time you were debugging an issue and the data you expected was missing. How did you proceed? In that situation, I focused first on narrowing the scope of the problem. Even without perfect data, there are usually signals that can help reduce uncertainty, such as timing, affected users, or recent changes. I talked to people who knew the system well to validate assumptions, and I used whatever data was available to form and test small hypotheses. After the incident, I documented what data would have helped and worked with the team to add that visibility, so we were not in the same position again. Describe a time when too much data made debugging harder, not easier. I have seen systems with massive volumes of logs and metrics where it was difficult to find anything meaningful during an incident. In one case, engineers were searching through logs that were noisy and inconsistent, which slowed response time. I helped the team focus on logging intent and outcomes instead of everything that happened. We reduced log volume, standardized fields, and made dashboards more focused. The result was faster investigation even though we actually had less data overall. Tell me about a time you improved observability and saw a clear impact. I worked on a service where incidents kept recurring, but root causes were unclear. I added request-level identifiers, improved error logging, and exposed latency metrics by dependency. After that, incidents became easier to diagnose, and repeated failures dropped significantly because we could finally see patterns instead of guessing. The biggest impact was not technical, but cultural, as engineers became more confident during on-call shifts. Have you ever had to convince others that better observability was worth the investment? Yes. I framed the conversation around outcomes rather than tools. Instead of talking about new platforms or dashboards, I talked about reduced downtime, faster recovery, and less stress during incidents. I also used examples from past outages where better data would have saved time. That made the value much clearer to both engineers and leadership. Core technical and scenario questions. Let us start with a practical question. When an incident happens, how do you decide whether to start with logs, metrics, or traces? I usually start with metrics to understand scope and impact. Metrics quickly tell me if the issue is widespread, which services are affected, and whether things are getting better or worse. Once I know where to focus, I move to traces to understand request behavior across services. Logs come last, when I need detailed context for a specific failure. The key is not choosing one tool, but using them together in the right order. Imagine metrics show elevated latency, but error rates are normal. What does that suggest to you? That often suggests a performance degradation rather than outright failure. The system is still responding, but more slowly. I would look for downstream dependencies, resource saturation, or increased load. I would also check latency percentiles rather than averages because a small percentage of slow requests can hide behind a normal average. This kind of issue often requires tracing to understand where time is being spent. Your logs show errors, but metrics look fine and no alerts fired. How do you interpret that? It depends on the nature of the errors. Some errors may be expected or handled gracefully, which means they do not impact users directly. I would check whether the errors correlate with specific requests, users, or conditions. If errors are frequent but invisible to metrics, it may mean we are not measuring the right things. That is a signal to review both logging and metrics definitions. How do you decide what should be logged versus what should be a metric? Metrics are for things I want to track over time and alert on, such as rates, latency, and capacity. Logs are for detailed context and explanation when something goes wrong. If a piece of data helps answer how often or how bad, it is usually a metric. If it helps explain why, it is usually a log. Mixing those responsibilities often leads to confusion and noise. You are working with a distributed system where traces are incomplete because not all services propagate context. How do you handle this? I start by identifying the most critical paths and fixing context propagation there first. I do not try to make everything perfect at once. Even partial traces can be valuable if they cover the most important flows. I also work with teams to make context propagation part of service templates and libraries, so it becomes the default rather than an afterthought. What is a common mistake teams make when adopting logs, metrics, and traces? A common mistake is treating observability as a one-time setup. Teams add dashboards and instrumentation, then never revisit them. Systems change, traffic patterns change, and what was once useful can become misleading. Observability needs regular review to stay aligned with how the system actually behaves in production. Let us go deeper into how logs, metrics, and traces influence real-world debugging and design decisions. Imagine you are responding to an incident where users report intermittent failures. Metrics show small spikes in errors, but nothing sustained. How do you approach this? I start by acknowledging that intermittent issues are often the hardest to debug because they hide in averages. I look at metrics broken down by time windows, percentiles, and dimensions, like region or instance. Once I identify a pattern, even a weak one, I use traces to capture failing requests and compare them to successful ones. The goal is to find what is different when things go wrong. Logs help at the end to confirm the hypothesis, not to search blindly from the start. You are asked to reduce observability costs because log and trace ingestion is expensive. What do you optimize first? I do not start by cutting everything evenly. I first look at what data is actually used during incidents and investigations. Logs that are never queried and traces that no one looks at are candidates for reduction. I also review sampling strategies for traces and log levels for different environments. The trade-off is between cost and confidence. I aim to reduce volume while preserving the signals that matter most during failure. A team wants to replace logs entirely with metrics and traces. Do you agree? I would not fully agree. Metrics and traces are powerful, but logs still play a critical role in explaining unexpected behavior and edge cases. Metrics tell you that something happened. Traces tell you how it flowed. Logs often tell you why. Removing logs entirely usually leads to blind spots during unusual failures. The right balance depends on the system, but eliminating one pillar completely is risky. You are designing observability for a system handling sensitive data. What concerns do you have? My first concern is accidental data exposure. Logs and traces can easily capture request payloads, headers, or identifiers that should not be stored. I make sure sensitive fields are masked or excluded by default. I also consider access control, retention policies, and who can query the data. Observability should help operators not create security or compliance incidents. During an outage, engineers keep asking for more dashboards. How do you respond? I redirect the focus from creating dashboards to answering questions. Dashboards are only useful if they help make decisions. In the middle of an outage, adding new dashboards often wastes time and increases confusion. I ask what we are trying to learn and whether existing signals can answer that. After the incident, I am open to adding dashboards based on lessons learned, not during the chaos. You notice that traces are available, but engineers rarely use them. Why might that be? Often, it is a usability problem, not a technical one. Tracing tools can be hard to navigate, and if engineers are not trained or do not see immediate value, they fall back to familiar methods. Another reason is incomplete instrumentation, where traces do not cover the paths people care about. I address this by improving critical coverage and walking teams through real examples where traces save time. How do logs, metrics, and traces influence post-incident reviews. They help shift conversations from opinions to evidence. Instead of debating what might have happened, we can point to timelines, request flows, and concrete data. This leads to more accurate root cause analysis and better action items. The quality of a post-incident review often reflects the quality of observability in the system. Imagine you inherit a system with good metrics, but almost no logs or traces. What do you add first? I usually add minimal structured logging around key events and errors. That gives immediate context during failures without a large overhead. Then I add tracing for the most critical user-facing flows. Metrics alone tell me something is wrong, but logs and traces help explain it. I prioritize changes that shorten investigation time the most. What is a subtle observability anti-pattern you have seen? One anti-pattern is over-instrumenting internal details while missing user impact. Teams sometimes track every internal queue and thread pool, but lack clear signals about request success or latency. This leads to situations where everything looks fine internally while users are unhappy. Observability should always be anchored to user experience. How do you know when observability is good enough? It is good enough when engineers can confidently answer questions during incidents without guessing, when they can explain what happened, why it happened, and what to change next time. It is not about having perfect visibility, but about reducing uncertainty to a manageable level. Let us move into some harder situations where there is no clean answer. You are on call. Users are complaining. Error rates are rising. Metrics are noisy. Logs are incomplete. Traces are partially sampled. Leadership is asking for updates every 5 minutes. What do you do first? I slow the situation down mentally. The first priority is user impact, not perfect diagnosis. I focus on confirming what users are experiencing and whether the impact is growing or stabilizing. I pick the strongest signal available, even if it is imperfect, and use that to guide immediate actions like rollback, traffic reduction, or feature disabling. I communicate uncertainty clearly to leadership instead of pretending to know more than I do. Calm and honesty matter more than precision in that moment. An engineer argues that adding more logging right now will help debug the issue. Another argues it will increase noise and risk. You have to decide quickly. I usually avoid making observability changes during an active outage unless there is a very targeted and low-risk reason. Adding logs can increase load, change timing, or create new failure modes. If we already have enough data to make a stabilizing decision, I defer logging changes until after recovery. If we truly lack visibility and the change is safe and reversible, I might approve it. But that is the exception, not the rule. Your metrics show the system is healthy, but customers keep reporting slowness. How do you handle the disagreement? I trust customers over dashboards. Metrics are only as good as what they measure. I assume we are missing something about the user experience. I look for signals closer to the edge like client-side latency, request-level percentiles, or region-specific data. I also communicate internally that metrics saying healthy does not mean users are happy. That mindset shift is important to avoid dismissing real problems. You have limited budget and can only invest in one improvement. Better logs, better metrics, or better traces. How do you choose? I base the decision on where investigations currently stall. If incidents often stop at knowing something is wrong but not why, logs might help. If we struggle to see impact or trends, metrics are more valuable. If we know where but not how requests fail, traces matter most. There is no universal answer. I choose the option that reduces investigation time the most for our real incidents, not hypothetical ones. Leadership asks for a single dashboard that shows everything. Do you build it? I push back gently. A single dashboard often gives a false sense of confidence. I explain that different questions need different views. Instead of one giant dashboard, I propose a small set of focused dashboards tied to specific decisions, plus clear guidance on when to use each. The goal is clarity, not visual completeness. You discover after an incident that the root cause was visible in the data, but no one noticed in time. What do you change? I avoid blaming individuals. I look at alerting thresholds, signal clarity, and cognitive load. Maybe the alert was too noisy. Maybe it fired too often to be trusted. Maybe it lacked context. I focus on improving the system so the right signal stands out next time, rather than expecting people to be more vigilant. If you made it this far, take a moment to reflect on how you answered these questions for yourself. Which scenario felt the most uncomfortable? Which one forced you to admit uncertainty? Those moments usually reveal the biggest gaps and the biggest growth opportunities. Observability is not about collecting more data. It is about making better decisions under pressure. The best engineers are not the ones with perfect dashboards, but the ones who stay calm, prioritize impact, and adapt when signals are unclear. If you are preparing for real interviews, pause the video and try answering these questions out loud. Compare your reasoning to what you heard. Notice where your thinking aligns and where it differs. Let me know in the comments which question you found hardest and why. That reflection is often more valuable than getting the answer right. If you want more interviews like this, covering real production trade-offs and decision-making, subscribe so you do not miss the next one.